Equivalent fractions. Well, first of all, you're probably asking yourself, what exactly does equivalent mean? So we're going to discuss what the word equivalent means in math. So you're going to go ahead and take these notes on the teacher side. Equivalent in math means that they are equal in value. That doesn't mean they're exactly the same. It just means that they have the same value or worth. So they're going to look different, but they still represent the exact same thing. Let's take, for instance, if you had so here's an example. If you had a $50 in your hand, so just a $50, right? What would be some equivalencies to a $50? We could do 2/4. That's equivalent to a $50. We could do 5 dimes. That's equivalent to a $50, which is also equivalent to 2/4. So do you see how they look different, but they still are equal in value? Whether I pay with a $50, 2/4, or 5 dimes, I'm still paying with the exact same value. They just have a different appearance. So that is what we're going to be looking at today. Is we're going to be using a number line, and we're going to be seeing how decimals can look different but still be the same thing. We're going to be using the number line, like I said. We're also going to use our models to visually see what's going on. If I had 1/10, I could also show you how 1/10 is the exact same thing as 10/100ths, because this was our 1 whole, these were our tenths, hundredths, and thousandths. This is from a previous video. And looky here. So 1/10 is equivalent to 10/100ths, which is equivalent to 100 thousandths. Those are all equivalent. I didn't change the size of the piece whatsoever. They're equal, but they look different. These are broken into tenths, these are broken into hundredths, and these are broken into thousandths. So if I had 2/10, that would be equivalent to 20/100ths, which would be equivalent to 200,000ths. So you can visually see how that works. And we're going to be using these models in workstations so that you'll truly get a grasp of equivalencies. Let's go back to the number line now. The first thing I'm going to do when I look at a number line, I have a beginning point and end point. And for this example, we're going to call this 0 and we're going to call this 1, because these are our whole numbers and the decimals are going to be the parts of the whole. They're not the whole thing, they're the pieces in between. When you are looking at a number line, the first benchmark you should decide on is your halfway mark. And we don't have to be perfect here, but just eyeball, and that looks about halfway, correct? The next thing I'm going to do is this would be my halfway mark. In decimals, we call that 0.5, which is 5/10ths, okay? Then we're going to do our benchmarks of our tenths, because we just had 5/10ths. I'm going to try to get these kind of on, and then we'll play with them and see how well I did the separation points, which looking like I might be okay. Okay, so let's label this now. If this was 0 and this was 5/10ths, we could go backwards to help us out. You could count 2. You've got 1/10, there's 1 2/10, 1 2 3/10. So this would naturally be 4/10. So these are your spots between. So let's use that same strategy to come over here and do from 5 all the way to 1 whole, because these are just decimals. They're fractions of the whole number. drag that. Okay, and like I said, best as I can do it right now, just free drawing it. We could measure it, but so if that was 5/10, that was 5 pieces. 1 piece, 2 piece, 3 piece, 4 piece, 5 pieces. Now we have 6 pieces, which is 6/10, and 7 pieces, 8 pieces, 9 pieces, until we're into 1 whole piece. And the reason these were tenths is because I broke it into 10 pieces. Now, when we're talking about equivalent decimals, we can also call 0.5 0.50. If we were to put little hash marks in between here where there were 10 in between each one, there would be 10, 20, 30, 40, 50. So an equivalent decimal to 1/10 would be 10 hundredths. And we could do this for all of these decimals. So it's just like adding a 0 beside it so that you can see that it has an equivalency. Just like when we were looking back at these, if we had the 2/10, we would write it as 2/10, and then we use those same 2, but I'm just going to draw over here so you can see. Use 2 of these guys. That is now 20 hundredths. Using 2 of the bars, because it's equivalent, is now 200 thousandths. So you, just by putting a 0 in there, you're still have the same amount. We use 2 pieces, but you're now creating hundredths and thousandths instead of just tenths. So in the number line, we could keep going on with this and just add another. We took those little hash marks that we could have put in between here, which is kind of small, so we went and put another 10. We've just powers of 10. Remember we talked about that? We've just increased it to the thousandths place. So we could look at it. I'm just going to do a couple of them just so you can see that these are still all the exact same value. They just look different. They are equivalent. 1/10 is equivalent to 10 hundredths, which is equivalent to 100 thousandths. So let's just look at this on a place value chart. If I had 3/10, it would be equivalent to 30 hundredths. And we can look back on this. 3/10 is 30 hundredths, which could be 300 thousandths. So all you are technically doing is sticking a 0 in the place next to it to increase the pieces, which would actually decrease the size, but you're not changing its value. 3/10 is not more than 30 hundredths, because if I put an imaginary 0 in here, do you see how they really are equal?